So let us deal with problem number 1.206. It is the 8th problem in this series. So the problem is stating, find the potential energy of the gravitational interaction of two mass points of masses m1 and m2 located at a distance r from each other. And in the second part, the problem is asking of a mass point of mass m and a thin uniform rod of mass capital M and length L, if they are located along a straight line at a distance a from each other. Also find the force of their interaction. So let's get started with this problem. So the first part is based on the standard result which we have, the potential energy of interaction between two masses m1 and m2 located at a distance r. So we can say we have a mass m1 and another mass m2. They are located at a distance r, and hence we can say that the potential energy due to interaction is equal to minus g m1 m2 by r. Since the force is attractive in nature, the potential energy is negative. Now in the next part, the problem is asking, find the potential energy of the gravitational interaction of mass point of mass m and a thin uniform rod of mass capital M and length L, and the separation between them is given, and the force of interaction is also to be calculated. So let us begin this problem by first of all drawing a diagrammatic explanation of the situation. So this is the diagrammatic representation of the situation where a thin uniform rod is placed at a distance a from a point mass m. So over here, as we approach this problem, so at a distance x from this point mass, we select a small elemental patch of thickness dx and having mass dm. So this patch is of thickness dx and having mass dm. So over here, if we use a linear distribution of mass, then we can say lambda equals m by L equals dm by dx, and therefore we say dm equals m by L times dx. Now if we write the potential energy due to interaction, so the first thing that we write is the potential due to interaction, or if we directly write the potential energy due to interaction, then we can say du equals minus g dm is small m by the separation between them, which is equal to x. So if we put this value, then we get the form minus g is small m capital M by L dx by x. Now if we look at the limit of integration, so we can say that the smallest distance of the rod from this end is equal to a, and the farthest distance is L plus a. So when we integrate this expression, so we get du is equal to minus g small m capital M by L integration of dx by x, and the limit of integration is from a to a plus L. So over here, if we solve this part, so we get the potential energy due to interaction is equal to minus g mm by L and ln b by a. So a plus L by a. So we get the final answer as minus g mm by L 1 plus L by a. Now the problem is also asking us to calculate the force of their interaction. So if we calculate the force of their interaction, so if dF is the force of interaction between them, so dF can be written as g small m dm by x square, and we will integrate this expression. So we get g small m dm can be written as m by L dx by x square, and the limit of this integration extends from a to a plus L, which we have already discussed. So on solving this expression we obtain f equals gmm by L, integration of 1 by x square is minus 1 by x, and then we can put the upper limit minus lower limit, and on solving this we obtain gmm by a plus L. So this is the final answer for this particular problem. So these two are the final answer for part B of the problem, and this one was the final answer for the first part of the problem. So this was 8th problem in this series, problem number 1.206.